Looking for a fast-charging, ultra-responsive stylus for your iPad? Meet the 2X Fast Charge Active Stylus Pen, designed for 2018 to 2025 Apple iPads. Take your creativity and productivity to the next level. Click the link in the video description to shop now on Amazon.
We're talking about solar flares and how they can impact Earth systems. NASA has just spotted 2 large ones in a 24-hour period, which could cause problems for our planet. According to NASA's Solar Dynamics Observatory, these are the strongest we've seen in a while, measuring X1.2 and X2.7 on the scale of solar flare strength. To put that into perspective, solar flares come in 5 categories: A, B, C, M, and X. Each letter represents a flare 10 times greater than the previous one. What's interesting is that activity on the sun's surface is cyclic. Every 11 years, our star reaches what's called solar maximum when this activity peaks. Scientists from NASA, NOAA, and the Solar Cycle Prediction Panel confirmed in October that the sun had reached solar maximum for this cycle, the 25th recorded. At this point in the cycle, sunspots, solar flares, and coronal mass ejections are more common. These eruptions can send high-speed particles hurtling towards Earth, affecting everything from GPS systems to radio networks and power grids. Devika Kamath, an associate professor in astronomy and astrophysics at Macquarie University in Australia, has been tracking these solar events. She explains that observations of the sun help space whether scientists determine when effects might be felt on Earth. The sun is continuously monitored by a network of solar observatories in space, she says. These observatories provide near real-time data, allowing us to detect solar flares and track coronal mass ejections. However, there's still a lot of uncertainty around predicting exactly which flare will cause trouble. Kamath notes that the alignment between Earth's magnetic field and the sun's magnetic field plays a crucial role in triggering geomagnetic storms. If a CME is confirmed to be on a collision course with Earth, we usually get 12 to 72 hours notice, she says. Long enough to alert vulnerable sectors, but not always enough to predict the severity or location of impact with high confidence. The Carrington event, which occurred in 1859, was caused by an X-45 solar flare and had a significant impact on global communications, damaging power grids and causing blackouts. Scientists are working hard to better understand solar activity so they can prepare for disruptive events. In Australia, the Bureau of Meteorology's Space Weather Services issue alerts and warnings to critical sectors like aviation and energy. The most relevant risks in Australia include GPS and satellite navigation errors, high-frequency radio blackouts, satellite anomalies affecting weather forecasting and communications, and geomagnetically induced currents posing a risk to sensitive power grid infrastructure.